Welcome back to this series. In our previous videos, we've worked with LLMs and chains, giving prompts and generating responses, and even combining multiple models to create structured workflows. Now we're moving into another fundamental concept that powers intelligent retrieval, search, and reasoning in modern AI agents: embeddings. So, what exactly are embeddings? Think of embedding as the numerical fingerprints of text. So, when we feed a sentence like Delhi is the capital of India into an embedding model, it doesn't just read it as words, it converts that text into a vector, which is a list of numbers. Each number in this vector represents a small piece of meaning from the original text. Together, they form a semantic representation, meaning that two texts with similar meaning will have vectors that are close to each other in this higher dimensional space. So we'll make this intuitive. Suppose if you take two sentences like Paris is the capital of France and Delhi is the capital of India, the embeddings will be very close because both talk about capital cities. But a sentence like I love pizza will have a completely different embedding far away in vector space. Now, why do we need embeddings? Embeddings are basically essential whenever we want our AI to understand the context or meaning rather than just a plain text. They help us with semantic search, meaning finding documents similar in meaning, not just by matching keywords. It also helps in context retrieval. That means fetching relevant chunk of information to feed on into an LLM. They help us with clustering and classification, which means grouping related ideas together, and they help us with recommendation system, meaning suggesting similar product or content based on its meaning. So in this video, we'll use Hugging Face embeddings, specifically all the specifically the model. In this video, we'll use Hugging Face embeddings, which is a lightweight and efficient. In this video, we'll use Hugging Face embeddings and a lightweight model from the Hugging Face embeddings. So we'll generate embeddings for a single query, that is the Delhi is the capital of India, and then a list of related documents. Then when we print them, we'll see a long list of numbers, and those numbers will be the numerical representation of our text. But what's more important is that we will use those embeddings to compare similarities, store them in a vector database, or build context-aware AI agents that retrieve information intelligently. So the main advantages of these embeddings are huge. First of all, they allow semantic understanding, meaning the model can reason about meaning rather than exact wording. Second, they make retrieval augmented generation possible or RAG possible, where an AI can look up context before answering. And the third, they significantly improve accuracy in search, question answering, and knowledge based systems. So embedding acts as a bridge between the language and numbers, allowing machines to understand and compare the meaning of provided text or document. And as we go further in this series, we'll see how embedding power intelligent agents, enabling them to remember, reason, and respond more accurately. But for now, we'll see the very basic implementation of these embeddings. So let's go into the code. Okay, I'm going to create a new folder here and then call it embeddings. After that, I'm going to create a new file. Let's call it Hugging Face Embeddings .py. Hugging Face Embeddings .py. Okay, now the import is going to be quite different here. So first of all, I think I'll need to install something. Let's go to requirements. Here I'll need to install LangChain underscore Hugging Face. Okay, I'm going to install these requirements. As everything else is installed, the new library will also be installed in addition to the other libraries that we already have. Okay, this is installed. Let's go back to our code, and then from here we'll import from LangChain underscore Hugging Face import Hugging Face embeddings. Then we'll import .env load.env, and then we'll also import OS. I'm not sure if this is going to be used or not, but anyway, let's import it. And I'll load my credential. Okay, so what kind of credential am I loading here? So to use Hugging Face embeddings, you need to visit the Hugging Face website and create your API key and then save it in the environment file here. So you can do that yourself or take the reference from the Hugging Face documentation too, or the LangChain's documentation, and then you can create that Hugging Face API key and then paste it in your env, and then that will be loaded here using this load.env function. Anyway, I'm not going to go to that. I've already placed my Hugging Face embedding key here, so I'm directly going to run this. So embeddings equals to Hugging Face embeddings, and then I'm going to use a model here that I found out in the Hugging Face model section. So this model is sentence transformers all mini LM L6 V2. I might also need to import sentence transformers here. So let me write that down and then install the requirements. Pip install -r requirements.txt. So while that is being installed, let's continue with our code. As I said, I'll have a text, simple text. Delhi is the capital of India. And along with this, I'll have some documents where I'll say Delhi is the capital of India. Kolkata is the capital of West Bengal. And then Paris is the capital of France. So what we can do here is, like I said, we can convert this textual data into numerical figures. So to do that, I'm going to use embedding model dot embed query, and then inside this, I'm going to pass this text here. So if you print this out, str result, if you print this out, then you'll see that this particular text will be converted to numbers. Okay, so let me run this now. The library is now installed. I can run this code now. It will take some time to run because the model might not be downloaded. So it will download the model first and then run our program here. Okay, so once I printed this and the code has run, we can see that this particular text is now converted into this combination of numbers here. Now this is called embeddings. Not only this, we can also embed our documents here. So if I just type, result underscore doc equals to embedding dot, since we are embedding documents, so we need to pass in embed documents and then pass in the documents in this list. Now if we print this, we'll see that we have embeddings for each of these text in a document. So we'll basically get a list of embeddings, and then each embedding will resemble each sentence that we see here. So I think you can run this program on your end and then see the result of your embedding here. What we'll also do is we'll also try to compare the similarity of this particular text with these documents here. So let's see what happens. What we'll do is we'll do result here and then result doc here. Now we'll compare the similarity score, and then for the similarity score, we'll use cosine similarity. For that, we'll need to import something here, or basically need to install a library. Install pip install scikit-learn, and then based on that particular scikit-learn library, we'll import from sklearn.metrics.pairwise will import cosine similarity. And now to compare our similarity embeddings between our text and our document, we'll use cosine similarity and we'll pass our result here, the result which is the embedding of our text, and then we'll pass our document embeddings which is result underscore doc. So let me print out the similarity scores here. So let me simply print out similarity scores, whatever we get here, and then run this program again. So as you can see, the text is the similarity between the text and then the first document is almost 98%. Similarity between the text and the second document is almost 47%, and the third document is 27%. Now if I add a new sentence like I love pizza here, we'll see that this similarity score is quite low in comparison to the above three sentences. Let's print it out. Let's clear this and then run this model again. So we can see that the text Delhi is capital of India is very much lower similar to I love pizza, which is almost 9% similar to pizza. So the highest similarity is these two sentences. You might get why we did not get 100% similarity, because here there is a slight mistake while I've typed this word. So if I type Delhi is the capital of India and then we get the same sentence here, it would basically be 100%. Let's see if we get 100% similarity between them or not. So yeah, we get 100% similarity score between these two sentences. So this is the importance of embeddings. Basically converting the text into numbers represent the semantic meaning of that particular text, which is easier for computer to understand. And everything from now on that we'll do will be based on these embeddings. Basically, if embeddings were not possible, retrieval augmented generation would not have been possible. So I'm going to end this video now. If you have any queries, feel free to comment down below and I'll try to help you out. And I'll see you in the next video.